Hello grade 12s and perhaps grade 11s as well. Welcome to my channel, and today we're going to explore algebra in a deeper sense. I know most of you are taught algebra in a very superficial way, perhaps in a way that is okay when everything is standard, but the moment questions that are rather out of the levels of the standards, then students start to flinch and even fail dismally. Remember, the higher order questions, which often cause problems for students, they need a deeper understanding of algebra and even the use of algebra thereof. So we're going to take a walk through a few questions that I looked and found, and to some extent modified to try and assist you guys in gaining the experience and of course the skills that you need to be able to handle these questions. Please folks, do not look at these 10 questions as merely things to cram as to how to get around the work, but rather understand every step and in fact the very essence of our choice in attacking the question, because this is what will help you guys in the future to be able to see things beyond what is obvious and be able to answer questions that are not so easy to answer. Okay. Remember, real life questions do not understand the standards that we have, so we need to adapt them into those. And perhaps we will find the solutions we probably would be looking for. So if guys you're interested in this worksheet, it's going to be algebra and number patterns. You can just go on into the description and check. I will perhaps try to write the suggested answers as best as I can as well, so that if you're interested in that memo as well, you can download it as well in the description. Now folks, with algebra, we need to understand the essence of how we solve problems in mathematics. So quickly guys, without wasting any time, the three-step approach needs to be understood. Okay, if you don't have this three-step approach in order, you'll probably have a lot of issues with higher grade questions in maths. Okay, so first of all, it's BODMAS. Okay, now with BODMAS, we know that we do brackets, we do ordinals or exponents, we do division, multiplication, addition and subtraction in that order. Meaning if we're given any expression, either to simplify or solve, we need to first solve what is inside brackets. We need to deal with ordinals, then do division or multiplication interchangeably, addition and subtraction again. We can do this interchangeably, all right? So this is the order of operations, okay? But now we can adapt this into other branches of maths. For example, in trigonometry, when we're doing simplification, we may include reduction formulae here, as well as cofunctions. In the part of brackets, of course, saying brackets off essentially. Then division and multiplication is when we are actually dividing factors out. And then addition and subtraction, we may be talking about the utility or the use of special angles. And I can tell you folks, this makes up 80% of our solving of mathematical problems. And just take a note that we tend to do the inverse operations, or rather the reverse operations, in any of what we're doing here. But sometimes we may be doing it in the forward direction. Of course, the second step would be to factorize. This is nothing but division and multiplication looked at simultaneously. So we can do this by taking out the highest common factor, or we can do a difference of 2 squares, or even a difference of 2 cubes. Right. Then sometimes for polynomials, we may rely on long division. Sometimes from long division, we then adapt this into some inspection techniques that we can use. For example, the bracket method. And of course, we do groupings, you name all the techniques that get to be involved here. So this is a very important technique to learn and to understand how to perform. Then, of course, step 3, folks, we may be using identities. Now, these are what has been established as true. And, of course, the laws, for example, exponential rules and set rules. We can also look at a formula. For example, the quadratic formula, or any other formula that applies in maths, or just pure logic, at times. Just know we can do certain things to some certain limits, of course. So folks, please understand this. I have spoken about this at length in previous videos. Please make sure you understand this rather than to cram it. Now folks, let's get to our business of the day. We are about to deal with these questions that I have compiled here. Of course, I did not make up most of them, but I kind of modified them to serve the purpose. Right, now let's consider the following. We've got x squared plus x plus 1 all divided by x squared minus x plus 1. Now, the question that we need to answer here is, what is the maximum and the minimum value of the expression? So essentially, our key activity is to uncover what is the maximum and the minimum for the expression. Of course, we call these rational expressions. Some may even call these rational functions or rational equations, depending on the setup, of course. Now, how are we going to deal with this problem, folks? Now, we have a fraction. Now, the basis of dealing with issues of maximum, when we've got a fraction, let's say, for example, we've got a over b. We need to understand this. For this to be a maximum, it means a must be the biggest value it can be. Right? And the denominator must be the smallest value it can take. Right, so this gives us a maximum. So we need to understand these, guys, because if we don't, then we're not going to find any solutions. And of course, with the minimum, the reverse is true. We know that if we've got our a over b, and we are talking about a minimum value, so this means this must be the smallest it can be. And of course, the denominator must be the biggest value it can be. Right, so these are the basics, guys, when dealing with fractions or rational expressions, and of course, looking for maxima and minima. Now, at a later stage, I may show you guys how to solve these, to graph these so that you can also read off these kinds of issues. Because if you know how to graph these, it's very easy. But when you don't, which is the case right now, so what can we use to find an understanding of this? As you can see, folks, I am showing you things that you probably don't get taught. Of course, these are overlooked with the impression that you would know these from, the previous grades. But these are sometimes not looked at because nobody sees them as important, because we tend to want to just teach what is going to be examinable and forget about what actually makes what is examinable actually examinable. Problem is the extent of the exams. We tend to just do routine work and call that exams. Exams cannot involve routine like classwork and homework and class test. examinations, guys, need to be different. And these are going to show you exactly how algebra should be examined, not the way that it is being examined. Of course, we can't say everything must be out, but most of the things should not be present because those are just pure routines. Unless we make them higher order, then that's what constitutes an exam. Right. So folks, we look at these expressions, we will see that, well, if we look at the expression above, it's a quadratic equation with an a value greater than 0. Folks, you have done functions. Now we integrate topics here. Remember, if you're solving this in the finals, whatever technique makes sense, you apply. So what does this mean? It means our parabola is concave up, right? So what does that mean? It means at the turning point, it has a minimum value. So now, remember, this is good because it can help us solve the next question of a minimum. But for a maximum, it doesn't really seem to work. If we look at the denominator, it's a similar situation. A is greater than 0. Now, folks, you've done functions. You need to know what a is. This is the coefficient of the highest power in the expression. So this means the coefficient of x squared. So if it is greater than 0, this is also going to be a graph that is concave up. And this also means that it has a minimum value at the turning point. Now this, to some extent, helps us to solve the maximum issue, but it gives us a problem for the for the minimum. Now we can clearly see that graphing these may not necessarily help us, but let's just walk around this problem a bit. Let's just say we were to draw these graphs on the Cartesian plane. Now, I'm just trying to show you guys problem solving skills here. Of course, this is not always going to work, but it works most of the time because all we want is to focus on understanding what we need to do. Now, if we look at this, we'll appreciate that, well, the one on the numerator is a parabola. By the way, if we complete the square there quickly, it's going to be x plus a half all squared plus. Now this is going to be 1 minus a half squared. So that becomes a quarter. 1 minus a quarter, 4 minus 1 is 3 over 4. So this means it's going to be 3 over 4 like this. So this is for the numerator. Now, folks, completing the square is something that you need to know also. It's very important. So all I know is that my turning point is to the left of the y-axis. So I've got a graph that does stuff like this. Or the second thing is, will this one have rational roots at all? If we just quickly look at the discriminant, b squared is 1 minus 4 into 1 plus 1. So this is minus 3. So the discriminant is negative. So this is a parabola that is flying instead. That's our parabola. Let me try to make it look nice. Hi, Wenaman. Right. So this is our parabola. It looks like this on the Cartesian plane. For the numerator, of course, don't worry about the arms not being equal. The y-intercept is at 1. And we know that the axis of symmetry is at minus a half. And we know that the minimum value is at 3 over 4. Right? 3/4. So that's the first graph. Now the second graph is more or less the same thing, but this one is to the right. Okay? So we can just simply copy this graph. Now, we know that this graph is doing exactly the same thing as the other one. Right. So if we look at this graph, still going to have the same minimum value, and of course the x here is going to be at a half. So if we look at these two graphs, automatically we can clearly appreciate that they do touch here at the y-intercept. But now if we continue increasing these elsewhere, will we have roots? Of course, 0 is a real number, but it's as good as nothing, so we can't really rely on that root. But we know that, okay, these ones as they stand, they may not touch. But for this to exist, it means there must be some point where they touch, if we continue these. Perhaps there, maybe if we continue, perhaps there as well. Because this one is almost as good as nothing. That root is 0, so yes, it is real, but we wouldn't really be convinced. So now how would we do this? Obviously, folks, if we tweak the expression on the denominator a bit, say for example, we make this graph more steep, I'm trying to think now what would be the best way to make this one steep. Okay, yes, it does it. Now, do you see, guys, if we make this graph more steep, of course, everything might change. Do you see that there is definitely going to be a possibility that they touch here? Although they may not touch this side, but they'll definitely touch on that side. And if we make it wider as well, the same thing, we make it wider and perhaps wider, let's say on this side, because this is the side that would give us what we want. Okay, maybe too much. Now let's say we make it wider. So can you see when we make it wider, there's a very good chance that these graphs would touch over there, although they may not on this side. So these are some of the things that we want to explore in questions like this, that if at all we manipulate the 1 on the denominator by multiplying it with something, meaning we are changing the gradients, because technically being wide and narrow means the gradients are changing. As you know, the effect of A has a very strong impetus. Is it so? Is it impetus? It has a strong implication into how narrow or wide this graph would look. So as you can see, this is basically us exploring these. So when would we get the biggest value if we manipulate this bottom one, which is this expression over here? So this is this graph. If we manipulate this one, what happens to it? Of course, assuming we're keeping this one constant, because for us to get a maximum, we don't want to change this. Since we can see it is itself giving us a minimum value at the turning point. So we want to keep the numerator the same, but manipulate the denominator to try and get to what we want. So as you can see, folks, this is very, very, very interesting if one thinks about it this way that I have just thought about it. Okay, so let's go back to what these graphs looked like. Okay, so this is where they stood at the beginning, but as you can see, if we just keep one constant, we want to explore what happens when we change the bottom one around so that we can serve the purpose of getting, the maximum as well as the minimum. But on the face value, as we can see, we would not necessarily know what to do. But understanding our task now, we can go on and solve this problem. Now, folks, we can clearly see there's no telling by just looking at this graph what's going to happen. Of course, I forgot to mention that even this one has irrational roots. So that's why those graphs will never touch the x-axis. But by their shape, they will be above the x-axis. All right, now let's get to solve this problem. So we've got A here. So folks, A would force us to do the indirect technique. Right. the indirect technique here is going to be useful, because we could see that when we face these graphs directly, at our level, we are not able to do much. But if we then try our algebraic gymnastics here, of course, that are very informed from previous grades, we can actually crack this issue right here. So let's go for it, folks. Now, what are we going to do? We will just say, okay, let x squared plus x plus 1 all divided by x squared minus x plus 1 be equal to k. Of course, this, we usually refer to this as the k method for those who did grade 11 in the country. So if we let this be equal to k, we end up with an equation. Remember, k represents nothing but the same expression, so nothing has changed here. We're just naming it. Remember, a child, when it's born, we give it a name. All right. Now, folks, what does this imply? This implies that we've got x squared plus x plus 1 all divided by x squared minus x plus 1 equal to k over 1. Remember, these are fractions. Now we just do our gymnastics, cross multiplication in this case, which is just nothing but multiplying by the common denominator, or the LCM, the lowest common multiple. Now all we can see is that the left hand side pretty much stays the same. As you can see, we wanted to do so. So this means it's going to be kx squared minus kx plus k. This is when we multiply, cross multiply. Now we can see that this is a quadratic equation, so we must write it in standard form. So we will bring in x squared and its friend. It's going to be minus kx squared. The next one is going to be plus x. We bring in the other x term, is going to be plus kx. Then we have plus 1 minus k equal to 0. Okay, so we're using all the techniques that we know. I'm going to trace for you the steps that we have employed here of our 3-step approach. At this point, we're just going to go as we know how. This is factorization by grouping. So we take out the highest common factor for the x squared. So it's going to be 1 minus k times x squared. Plus we do the same here. It's going to be 1 plus k times x plus 1 minus k equal to 0. Now we have written our equation in the form ax squared plus bx plus c equal to 0. So this is always the target when we've got a quadratic equation, because for us to be able to solve it, we must write it in standard form at least. Now, folks, what did I say? If at all this thing is to be real, or it means this thing, for us to solve it, it must exist. Now, if it has to exist, remember we equated the two. So what do we mean by existing? It must have real roots. So this is very important. Now can you see technique of nature of roots? Because for us to solve this, it has to exist. Because now at this stage, we don't want to go through the trouble of, using the quadratic formula. You can if you know how to, but it can get very complicated with terms under the said not really helping us to solve. So we avoid what is going to give us a long lengthy situation. We can just say for real roots. What do we know? We know that delta must be greater than and equal to 0. So this is very important. Can you see, guys? Very, very interesting stuff. Did you see when we manipulated our graph, there were points of intersection that we knew would happen even though we don't care where exactly. So those are real roots. That's what we mean. So this implies, can you see we are using a formula now? B squared minus 4AC must be greater than or equal to 0. This implies B, remember B is the coefficient of x. So this is going to be 1 plus k all squared minus 4. Now what is a here? A is the coefficient of x squared. So this is 1 minus k. C is the constant, right? And the constant is complex term here. This is our C. So we write it as it is, 1 minus k greater than or equal to 0. Now we simplify further. So this is going to be 1 plus 2k plus k squared minus 4 into 1 minus 2k plus k squared greater than and equal to 0. We go on, so this is going to be k squared plus 2k plus 1 minus 4 plus 8k minus 4k squared greater than and equal to 0. Now we've got like terms, k squared minus 4k squared. What does this give us? It gives us minus 3k squared. Then we go on, plus 2k plus 8k, this is plus 10k. And then we've got these two giving us minus 3 greater than and equal to 0. Now we've got a nice quadratic expression here, which we can attempt to factorize. If it doesn't work, quadratic formula, guys, 3k, k. Now if we want 10, this must be minus 3 plus 1. Right, so we get 9 plus 1, that's 10. Now once we get to this, folks, now there's a few techniques that students may need to look at to solve the problem. But now I will show you the first one. The first one is the graphical method. So what do we see? This expression essentially has a coefficient of x squared that is negative. So this means it's a grumpy face parabola and the y-intercept is negative. So this is something like this. Now we are adapting this. What expression on the left is it? It's a delta expression. So this is the discriminant, origin, and the variable is k. So what does this graph look like? These roots are both positive with a negative y-intercept. So this is the graph like so. Sunpapela, do the things, man. Yeah, man. Can't do the other things that I didn't send you to do. So there we have it, guys. So we know that essentially, if we can just get rid of our origin there, put it on this side. This is minus 3. I always prefer to do a near perfect sketch. This is going to be a positive third. This is going to be a positive 3. Now we want to find out when is this graph equal to 0. We can clearly see that the graph is equal to 0 at these intercepts. When is it above 0? In between the two intercepts. So this is just to illustrate that these k values in between give us what we want. So essentially we connect the bar like this because those are the solutions for k. So we can write here, therefore, our k must be less than and equal to 3, greater than and equal to a third. Right. So now we look at this. What is k in the first place? We knew that k represented the entire expression. And what are we trying to solve? The actual expression. So it means k, if it must range between these two. This is the maximum value. Right, so we can say therefore the maximum value of the expression is equal to 3. Nice and easy. Then you see, would not have known this, but an indirect technique that is itself quite complicated took us home, okay? And of course we can make the last conclusion. Therefore, the minimum value of the expression is equal to a third. So that's it. That's it, guys. So I ran out of space there. Anyway, the job is done. So folks, how would you score marks here? And by the way, k is any real value. Sometimes I like to show this because some people don't know, but the inequality themselves actually cover that. But I sometimes prefer this being stated because many people take this for granted. So can you see, guys, it means the smallest value that this expression, for it to be real, is when it is equal to a third, and the biggest it can be is that in between, well, it does its own things. So we are happy, guys. So let us enjoy the marks. So how many marks would you score for something like this? Of course, the technique of equating this to k or naming it k, perhaps we can say we get a mark for this because it was not given. So it's a way of getting to business. And then, of course, writing our expression in standard form. The gymnastics, we don't really care. So that's 2 marks. And realizing that we need the discriminant expression. But we don't get a mark for this, but we actually get it for the substitution. And when we factorize part of the 3 steps, we get a mark. And of course, for the solution, yes. And then writing these 2. So how many marks would be this? 1, 2, 3, 4, 5, 6, 7. This is worth 7 marks. So as you can see, guys, some questions by design can horrify you because they are there to chow your confidence, to destroy whatever you thought existed in new formats. So as you can see, guys, indirect techniques, it's like when you want a girl at school. If you know her friend, even if that one get trouble, and then all of a sudden it's as if it was so easy, you know. But others are easy to approach, of course. They are standard women, but others are not standard women. Okay, let's not say women, girls. All right. Now, guys, we've done it. So I hope you fully understand the technique. Now, what I would like to use as an alternative for this technique of using the graph, I'm doing this because I understand that students should know it. But the table method works. We just take the factors minus 3k minus 1. Then we take k minus 3. We put them on the table. I need you guys to master these 2 techniques. They are very, 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 very important. Please make sure you understand them. Now we list our solutions in ascending order. The third comes first, the 3 next. Now we ask ourselves, by the way we are doing the product, this is where we read our solutions in here. Now let's see, when would be the first binomial be equal to 0? When this is a third, when k is a third. Well, if we put a value greater than a third, what happens to that expression? You can almost see that it remains negative. So this is going to be negative, negative, negative. And then we say if this is a binomial, it means the other side should be positive. But again, you can check it. I mean, you know most these things. And then we look at the next one. When will it be 0? When k is 3. If we put a value greater than 3, this becomes positive. And if one side is positive for a binomial, there's a 0 and the other side should be negative. Now we do the product. Positive times negative is negative. 0 times any number is 0. Negative times negative is positive. 0 times any number is 0. Negative times positive is negative. So what do we want? This solution must be 0. So we've got solutions here and there. Are they included? Yes. The equal sign is there. And where else do we go? We want it to be positive. It is positive in between. So this means from here, we can draw that conclusion as well. So please, folks, master this. I know you guys like the number line. Be my guest, do it. But if you don't know restrictions, especially when you're given logarithmic inequalities, remember they can be asked. The fact that they have not been asked recently doesn't mean they won't come. There's a whole lot of restrictions that need to be understood. Sometimes I find the table of signs more appropriate because it covers a lot of things that you would not think about. The number line may somehow mislead you if you're not careful. But again, guys, if you master your technique, by all means, go for it. So folks, this is a detailed solution for that question 1. I hope you understood it. If you want more of these kinds of questions, please go to a video in the channel from November 2005. That was a paper I set for in the finals. There is a similar question to this. So you can go and have a look at it to further expand what we just did. Okay, let's look at question 2. Remember, guys, here we're just trying to get something going. So don't panic too much. Now we're solving for x, your favorite question, isn't it? So we've got 4 into 3x squared plus x. Let's just copy this. So we've got 4 into 3x squared plus x plus 1 minus 10 into 3x squared plus x minus 1. All that divided by 3x squared plus x equals 7. So now we need to solve for x. Of course, for me, folks, quadratic equations should be asked in this manner so that you can see it's not direct. Because when it is direct, you start to mess around a bit. Right, let's see, what are we going to do about this? Now, folks, this is not usual. Of course, the first instinct is to just expand the brackets and hope everything is going to go away. But we're going to end up with the exponent of 4 because this multiplied by that eventually is going to create a chaotic situation. Remember, in metric, we don't really expect you to deal with chaotic, expressions. But yeah, how do you avoid them? Skill. So folks, we realize that, okay, the standard approach here is not going to really work in our favor. So again, what can we do? Indirect approach, guys. So what do we do with the indirect approach? We look what is common in these. You see, this 3x squared minus x is here too, as well as in this denominator. So we can try and name it something. So we'll just say let 3x squared plus x equals k, the k method. This is again an indirect way of getting to the solution without struggling. So what does this imply? It implies that we've got 4 into k plus 1 minus 10 into k minus 1 all divided by k equals 7 over 7. Sorry, over 1. Now, of course, this is all over 1. If we want to deal with fractions, then we multiply by the common denominator, which is k. What do we end up with? We end up with 4k into k plus 1 minus 10 into k minus 1. So it goes away from there, then it becomes 7k. Now we can see that there's no other plan now but to FOIL. So this is going to be 4k squared plus 4k minus 10k plus 10 equals 7k. Oops, not 77. And then let's go on, folks. Collect like terms. So this is 4k squared. Now 4k minus 10k is going to give us minus 6k minus 7k. This gives us minus 13k plus 10 equal to 0. Now we've got our quadratic in standard form. We can factorize. Of course, folks, you check the discriminant of that quadratic expression. If it is a perfect square, it means factorization is going to work. But if it is not a perfect square, don't waste your breath. Go straight to the quadratic formula. But now let's try and plan our things nicely here. For us to get 13, we need to break the 10, but perhaps leave that one. So let's just say this is 4k and then k. Now, these must be both negative, so we're going to have minus. But if we just plan it nicely and put a 2 there and then a 5 here, this is going to work because 4 by 2, that's 8 plus 5, that's 13. So we are done. Now, what are we going to do here? We know that from here we understand that k is going to be 5 over 4. Or k is going to be 2. Right, so this implies further, what was k? It's 3x squared plus x is 5 over 4. Or 3x squared plus x is equal to 2. Can you see, guys? Pain. Now, what do we do? Multiply here by the common denominator. 4 by 3, that's 12. K squared plus 4x minus 5 equal to 0. We're writing our quadratics in standard form. We get 3x squared plus x minus 2 equal to 0. Now, again, folks, we can attempt to factorize or use the quadratic formula. You never know which one is which. But let's just check the discriminant on each before we waste our time. So the discriminant is 4 squared minus 4 into 12 into minus 5. So this is 256. That's a perfect square of 16, right? So essentially, we can factorize this. So I always use the discriminant to just screen what I can factorize and what I cannot. Because at times you don't want to sit here too long trying to solve an impossible situation. Now, factors of 12 is 6 and 2. Let's see, 6 and 2. 2 by 5 can give us 10. 10 minus 6 is going to give us 4. So I'm happy. So let's see, this is going to be 6k. This is going to be 2k. And then we want the 2 to go with the 5 and then with the 1. Right, so which one must be bigger? It's going to be the bigger one, the 10. So this one must be positive. This one must be negative. This is done and dusted. The next one here, we're going to have 3x, x2 to get plus 1. So this must be plus 1 minus 2. So this is good as well. So what do we have now? Did I put k, guys? Excuse me. There's no longer k here. This is x. Oops. K is long gone. Okay, good. Now we can make a conclusion that our x is going to be minus 5 over 6. Or x is going to be equal to a half. Or x is going to be equal to 2 over 3. Or x is going to be equal to minus 1. Now remember, with rational equations, we cannot divide by 0. So now we need to come back and check, is there a possibility of these solutions giving us something like 0 in the denominator? So we want to go back and check, is there anyone that makes that expression 0? So let's check. 3 into minus 5 over 6 all squared minus 5 over 6. So this is positive, so it's not 0. As long as it's any other value, that's good. And then, of course, folks, we change the gears a bit. We put a half in there. Please, guys, run these checks. Otherwise, you're going to run into some serious bad solutions. And then you're going to say maths is hard when you are the one who's complacent. Again, I'm getting a quarter, so that's good. Then what about 2 over 3? So please, folks, be patient with the process. It helps to really be meticulous. And then again, I'm getting a positive answer. And of course, minus 1 is going to give me a positive answer. So I can already see that all these solutions are good. So please, I'm going to write here NB. Check that in the expression or equation, that in the expression or equation there is no division by 0. Number 1. And that the left hand side is equal to the right hand side. Because it's easy to think these solutions are going to work. But obviously, folks, I'm happy with these ones. We can go back to the original though. This is going to be more tedious process. You just take every x value you plug into the original equation and you check that the left hand side is equal to the right hand side. Because some solutions here may not be true because of our indirect technique. It may yield some extra solutions that we didn't have, but this one was quite friendly. So usually this is introduced by squaring or cubing or quadrupling or whatever you call it. But since we did not do that, I would trust that these solutions are good. So we can essentially accept these. But do run the check. Do not be complacent. So how many marks would a student score here? Yes, yes, yes. This is mark worthy. Naming it, then substituting it is good. Factorizing it is good. And then after that, these two solutions are good. And then we just mark each one of them. This is me being generous, but some people may just say 1 mark for 2 and maybe 2 marks. But of course, I'm just trying to be as outrageous as possible. 1, 2, 3, 4, 5, 6, 7, 8. Okay, you would not necessarily get 8 marks. That is not good. So from here, folks, we can say for each set of 2 correct solutions, 2 marks. So 1, 2, 3, 4, 5, 6. Yeah, this is good for 6 marks. Right. So anyway, folks, you can see that this is not an easy process. It's quite a tedious process to go through. So the check, folks, is very, 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 very important, especially with rational equations like these. We must never have a division by 0, because some of the solutions can actually lead to that. And we must ensure that the left-hand side is equal to the right-hand side so that we can accept that the solutions we got are actually correct. There's no need to wait for the memo in these kinds of questions, especially in algebra. Right, let's go to question 3. Okay, guys, I'm going to move a bit quicker later on. I just wanted you guys to understand the process, why we do what we do. By the way, I said I was going to try and map for you guys the steps that we have gone through. First of all, we can call this one logic. This is step 3, when we decide to create an equation. So this is the indirect technique. Substitutions and gymnastics and what we don't really care about. But we care about when we write this in standard form. This is the law. You can still call this one step 3. Now we start using the nature of roots. You can consider this as a formula, logic, or an identity, whatever you call it. This is still step 3. We substitute, we do the gymnastics. When we factorize, this is step 2. It's mark worthy. And then we use whatever means to solve. Then we get our solutions. And then from our solutions, we make our deductions. As you can see, folks, this is just as good as that. Perhaps you can call this one step 1, if you will. This one as well would be part of step 1. It's a technique of some sort. Anyway, so this is how we solve problems, folks. Let's look in the second one. Again, the logical technique would constitute step 3. Then we do the substitutions. We're not impressed by that. When we factorize, we get to step 2. Then, remember, everything else is step 1. So I'm not going to worry about step 1 at this point. Then we substitute back and then we solve again. This is all step 1, largely all the way to the answers. We check these. As you can see, folks, in between, we are using step 1, but I don't want to write step 1 everywhere. Now that you understand, I'm not going to bother, so you will find yourselves checking exactly which steps have we employed in solving the next few questions. Of course, there's lots of them. There's 10 questions here, and let's see if we cannot finish them all. So we're told here, for which values of x is this rational expression equal to 0. Now when we've got a fraction, let's talk notes now. Guys, please master these things. When we've got a fraction a over b, and this must be equal to 0, what does it mean? It means the numerator must be equal to 0. Because 0 divided by whatever number you may have on the denominator will always be 0. So we don't focus on the denominator for this one because of what we understand. It means the denominator must be the numerator must be 0. So now let's go for 3. Okay, let's write this. Okay, let's just say 3.1. For this to be equal to 0, it means x minus 2 into x plus 1 must be equal to 0. Therefore, x must be 2 or x must be equal to minus 1. But remember, once we finish here, we must go check if we don't have a situation developing, because the x value that we put here will also affect the denominator. It cannot be 0. So we can clearly see none of these two solutions give us a 0 on the denominator. So this is good. So this is good, folks. So what is important is to know that we need to do that and then do this. We can say 3 marks, we can say 2 marks, but do not forget, check that the denominator is not equal to 0 for each x value found. Ne? Yes, guys, this is very easy. 3.2. And you can see, guys, this is nothing but still quadratics. But how we ask it may shake you a bit if you don't know what you're dealing with. Now, when is this undefined? Now, we can clearly see that if we've got a over b, and we are saying this must be undefined, what does it mean? It means the denominator must be equal to 0. So essentially, that's the idea right here. So this means, folks, we are focusing on this technique now. So we don't worry about the numerator. Whatever it is, we don't care. For this to be undefined, we look at the denominator. It means x minus 3 must be equal to 0. Therefore, x must be equal to 3. That's it. We don't need to worry about it because this is self-explanatory. If you put 3 for x on that denominator, we get 0. And that whole expression becomes undefined. Most likely 2 marks for this. But again, I'm being generous. You may just be given 1 mark. Right, so let's get to the next one. Question 4. Question 4 says, find the numerical value or values of p such that x squared plus p into 2x plus 7 plus 8 is a perfect square. So what do you understand by perfect square? We know that once you've got a quadratic expression that is a perfect square, it means it has equal roots. Now, equal roots, what does it mean? Discriminant must be equal to 0. Oh my God. So this, we can use an indirect technique. Instead of solving this directly, once you understand what the question wants, folks, the whole thing becomes a pap and place. This is x squared plus p into 2x plus 7 plus 8. Now, of course, we can make this an equation if we like. Now, we don't really care here. We can say equal to 0. We can say here 4 equal roots what is it? It is such that the discriminant must be equal to 0. So this means b squared minus 4ac must be equal to 0. We substitute, oh my goodness, I forgot. We needed to do something here before I did the things. Okay, let's just do the things. So this is going to be x squared. Multiply p here. This is just going to be plus 2px plus 7p plus 8 equal to 0. We must write it in standard form. Otherwise, we're going to run into problems. So now let's see. So b here is 2p squared minus 4 into 1 into 7p plus 8 equal to 0. So we get 4p squared minus 28p minus 32 equal to 0. We can divide by 4 to make it nice and easy to handle. So this is p squared minus 7p minus 8 equal to 0. We can factorize now. But check the discriminant when you're not sure. So this is p minus 8 plus 1. We can say therefore p is going to be minus 1, or p is going to be 8. Now with these kinds of questions, it's not so easy to solve this problem, but I can tell you guys, you can take these p-values. You can still check, but it probably is going to be a bit more tedious. Check that the state given is true. You can check for equal roots. So we substitute the values of p. We say p is -1. We put it back in there. Then we see what this equation looks like. Is it a perfect square? And then we take 8 and put it there. We check and see if it is a perfect square. Never forget to check. Whatever is going on can be done. But of course, if the gymnastics and everything was done properly, this should not be a problem. So of course, guys, to know that we can equate this to 0, because once we talk about this being a perfect square, it means we're saying that there are going to be roots. For roots, we must equate this to 0. And essentially, we then interpret this when we substitute here, when we factorize, then we get the values. Sometimes you can get 1 mark, sometimes 2 marks for those answers. So how many marks? 1, 2, 3, 4, 5. This would be worth 5 marks, 4 at a minimum. All right, folks, so you can already see that nature of roots can be asked in a way that would not make sense if you look at it carelessly without reflecting on what the question actually wants from you. So folks, know these things. Now the other thing that another student can do, in maths, guys, you can actually look at mathematical expressions in any way that you choose. Let's say, for example, we took it directly. This is the indirect path. Let's just look at it directly. This is going to be plus. We just expand nicely. We're going to get 2px plus 7p plus 8 equal to 0. Now, folks, if we're saying this is a perfect square, we can just use this by completing the square. When we complete the square here, we're going to have x minus, we halve the coefficient of x, we then square it, but I think I'm not quite happy here because let me see if I'm doing the right thing. Yeah, let's do it. We have the coefficient here is going to be what? This divided by 2 is just going to give us p all squared. Then we're going to have plus 7p plus 8. And then we immediately subtract that business. This is just going to be p squared. Equal to 0. Of course, we don't need to say equal to 0 here because we're using completing the square. Now, folks, can you see this is already a perfect square? As it stands, it is already a perfect square. Now, if this is to be a perfect square, it means these two must be equal, because it means this must cancel that. So what does this mean, guys? So this implies that 7p plus 8 must be equal to p. What is this? This is p squared, because that's what we would get, isn't it? Because then this must kill that to leave us our perfect square. Let's see, we end up with p squared minus 7p minus 8 equal to 0. And then, of course, if we take it to this side, you will see that we factorize our business. So we get p, and what is this? It's going to be minus 8 plus 1. So therefore p is minus 1, or p is going to be 8. Can you see it still comes out even directly when we're using the technique of completing the square? But here we need to apply our logic to know that for us to isolate the perfect square, which is already what we want, then it means these two must kill each other. And for them to kill each other, they must be equal. Hence, we do that. Then we solve. So in maths, guys, you can do anything. As long as you understand maths. Remember, we don't teach you to complete the square so that you can only do it when you are told, solve this by completing the square. You need to use these to your advantage by understanding what you have. If you don't understand what you have, you will be dead. I promise you guys. You will be so dead, you will wish, you will wish that you didn't try to kill yourself. Mina ngikufundisa amaqhinga we-maths. Ngofama liba wa-mathematics. Folks, to be even able to write this expression like that is key. Then this deduction is key. Then of course this solutions right here. Good. And then the factorization most likely. So we would still get our 5 marks. Even though here we didn't suffer as much as we did when we had to use the discriminant and create an equation. That was in the indirect pathway. This is the direct pathway. You choose which one works for you. So in maths, beautiful guys. You do what you can handle. And you can see, guys, even certain techniques are not going to be taught in class. I probably, in fact, I can tell you this second one, you would not think about it if you did not sit back. This is why, folks, I advocate, excuse me that I sometimes, go on editor and heavily so. But I just want to emphasize these issues. I just hope I'm doing a good job because sometimes I may be very terrible at it. All I'm trying to suggest is that, guys, if you don't learn a technique, first, you just have to learn how to do it and be good at it, of course. But secondly, look at what benefits does it provide. Every time you are faced with a question, see if you can use it. You don't always have to know. In fact, it won't always work. But sit down and look at it and see, would you be able to use it? Because remember, in maths, guys, no one is going to tell you how to solve a problem. It doesn't matter if the exam guidelines are telling you must do 1, 2, 3. If you didn't do it, so what? At the end of the day, if you've solved the problem, this is good. Remember, mathematics, guys, is an open field. Nobody can tell you how to do it. Of course, if there's a technique we don't expect a matriculant to have and it's heavily taught at universities, then it means there's some chicanery, of course. Or at least who's a student is Popeye. You are the forward ones, I guess. Anyway, guys, I hope we are learning. So, as you can see, guys, you need to understand the question and then understand what to do. Now, let's get to this question 5. It's quite an interesting question, I tell you. As I was copying it, I was like, what? Do I even remember this? Some of these things, guys, I've forgotten. So you will bear with me when I take a long route in solving them, because my only issue is that this is all rusty in my mind. But I sometimes have ways to recover that, to dust away that dust. Wow. Saying the same thing more than one. I'm on a tablet tablet. It says now, given that m plus 1 over m is equal to k. Now you see we are told this is equal to k now. Okay. We don't have to make it equal to k. Write the following in terms of k. Now this was a popular question back in the days. And in fact, in trigonometry, you will almost always get a question of this sort. But hey, you can do it in algebra. Now, we've got m over m squared plus 1. We've got m squared plus 1 over m squared. M cubed plus 1 over m cubed. Okay, how are we going to get this business going? Well, we first write what we are given. Sometimes you just write, guys, given m plus 1 over m. Don't be lazy. Order in maths, guys, is key. Precision is golden. Right, now we start answering. A, because we need to see if you knew and understood what is being asked. Now we've got m over m squared plus 1. Now, folks, if we look at this and look at it good, we will see that, hey, we can solve this one directly. What is 1? is m squared over m squared. This is equal to m over m squared plus m squared over m squared. Remember, in maths, guys, this is a multiplicative identity, so we can create it by any ratio that we choose. But now our guide is this friend. This guy is the friend that informs us in doing this, okay? So there's always clues around you. So we go on, we cannot do much about the numerator, but now we can factorize this. How are we going to do it? Taking out the highest common factor. What is the highest common factor? Is m squared, okay? So we're going to have m squared. No, do we want to take m squared? No. We want it to look like the other one, so we're going to take m. So let's take m. No, man, Kirang. We don't need m squared here. It's on board. See, guys, I am rusty buffet. We can just make it m over m because we want it to look like that eventually. So we try to be not so bad about it. So this was a bad information. So now we take out the highest common factor, m. So what do we end up with is m plus the m on the numerator is out. It leaves 1 over m. Isn't it like this one? It's one on we born. And the good thing is these are now factors that divide to 1. Nice and easy. So we've got 1 over m plus 1 over m. So this is as good as 1 over k. Nice and easy. Okay, some questions in algebra, you can look at them directly, others you may not. Okay. It's up to you. It's up to you. You and me. Me and you. You and me. Me and you. Ne. Yeah, mos. It's like this thing. It's like this thing. Right, folks. I'm trying to think now. Where would the marks be? This guy. Good. Factorizing, yeah. Getting that expression and a final answer. A good easy 4 marks, yeah. This is an easy 4 marks. If at all you kept this thing going. Right, so let's get to B. I don't want to start B here because it doesn't look nice, but let's try. B, we've got m squared plus 1 over m squared. Now what is this, guys? If you think about it, this is as good as a sum of 2 squares. So this is as good as a squared plus b squared. Because I mean 1 is a perfect square, m squared is a perfect square, so that whole thing is a square. That whole thing is a square. Now these are the ones that provide a bit of an issue. So now how do we rescue ourselves? How can we express this differently? Now you may think about identities. Identities in grade 10. This is when we talk about the sum of 2 squares, a plus b squared. What is it equal to? Well, if we chose this, you would know that from the identity it says we've got a plus b all squared, right? Plus 2ab. Am I correct? Okay, I don't think I remember it well, but the way I remember it is you just take a and you take b, you square that thing. What happens? We get a squared plus 2ab plus b squared, and then we take the squares together. A squared plus b squared, we transpose the 2ab, so it's going to be a plus b all squared minus, so it's not plus, it's minus 2ab. So yeah, you see, this is how you remember these things if you've forgotten them. You don't have to cram these because they're not going to be provided in the exam. Can you see? Once you forget how to do an identity, just create it. Even if you didn't know it exists, this can help. So we can clearly see this works. Okay, this works. So we can try this technique and see. So this implies this is equal to, of course, so we take this m plus this 1 over m. Maybe I'm not writing it in the manner that I should. So we write, this is m plus 1 over m. We square that thing. Then we subtract 2ab. Sorry. Now 2ab is nothing but this times that times 2. So this is just going to be minus 2. Or if you will, you're going to say 2a, this is m squared times 1 over m squared. You will actually appreciate that these ones go away. And then it leaves just the 2. So you can just do it. No one is going to ask you, where did you get this? Hey, it's an identity. Now what is that, guys? This is k all squared minus 2. So this is nothing but k squared minus 2. So we've done it. Is clear. So a bit of logic, identities, step 3, as you know these things. You know, if you don't remember, you create it, okay? So this writing is mark worthy because, I mean, it's a gift from God. It's a gift from God, so the final answer. So usually for this one, most likely 2 marks. But if I want to push it, I can say 3 marks for the substitution. I mean, why not? But of course, at most you will say that this would be 2 marks because it's not quite a lot. Okay, folks, so that's how we do it. That's how we do it. I'm also thinking with our identity, we can even use a minus b all squared. This would be a squared minus 2ab plus b squared. Can you see we still get these guys? Perhaps this is what I was trying to think over there when I put the positive sign. So basically means a squared plus b squared is going to be a minus b all squared. When we transpose it becomes 2ab. Good. So if we used that, then we'd run into problems because this one has a positive sign between these. Now this one would have a negative sign between them. So we would not necessarily win. So probably that identity would not be better suited for the job. Okay, guys, remember these things. Remember these things. These identities are your friend. Okay? Don't forget them. These ones, let me just use this. These ones are your friend. Yes, you can remember them if you want, or create them. Okay? Create them. Of course, this one, or wherever you like it. So please, those ones are to be known. If you don't remember them, please, you can see it's so easy to create them. So this is why when you study these things, folks, don't just focus on cramming your way through. It helps to do so. Yes, at first a bit of cramming is going to be involved, one way or the other. But try to understand the proofs, because with these textbooks, of course, your textbooks suck, folks. I want to say it for free. Your textbooks suck because they don't prove anything they say. Our textbooks, folks, if you look at the Classroom Mathematics for Standard 8, it was sort of like creamish, yellowish book. You will see that every idea or concept has a proof of some sort. And these are the things that help when you forget, because you can't remember all of this under pressure. But if you know how to create these things, it becomes so easy. The whole thing becomes a joke while others are crying. Anyway, guys, we have done our job. We have done our job. Here, if you just didn't know, this is an identity. We used our identity. We used the identity. This identity, which says this is going to be a plus b all squared minus 2ab. This is an identity. In arithmetic, or even algebra for that matter. Sometimes it can be brought in an arithmetic question. You know those 1.3 type of questions, 1.4 type of questions that horrify you guys. It's what you actually know, but you don't remember. Anyway, let's not sit on this one. Let's do C, nice and easy. C, we've got a sum of 2 cubes. You see now? Right, so again, this forces us down memory lane. Do you remember how to deal with an identity of 2 cubes, like a cubed plus b cubed? What is it equal to according to the identity? Of course, sometimes, as I say, I don't remember this one, but Fetu must say create. So we're going to have a plus b. We cube it. So this is going to give us a cubed plus oh, ingathi izoba complicated nje na. Okay, masiqale. A plus b into a plus b into a plus b. That's what this is. Okay, maybe I should have done that. So we've got a plus b all cubed is going to be a plus b into a plus b into a plus b. Do you see, guys? Just do your thing, man. Now what do we get? We first start with the trinomial. So this is a plus b into, we're going to have a squared plus 2ab plus b squared. And then we distribute this, we get a cubed plus 2a squared b plus ab squared. And then we're going to have plus a squared b plus, maybe let's push you around a bit, plus 2ab squared one more time, plus b cubed. Okay, so now let's see, we've got a cubed. Now we've got 2a squared b, 2a squared b. So what is that? This gives us plus, no. So this one is 2a squared b plus a squared b. So this gives us 3a squared b. And then we're going to have again 3ab squared, right, plus b cubed. Now, this is easy because we can do this, right? Yeah, we can do this. Now, folks, remember, the left-hand side is still a plus b all cubed. Now we take these and keep them on one side. So when we do that, we're going to have a cubed plus b cubed equals a plus b cubed plus 3a squared b plus 3ab squared. Right. In fact, I'm thinking I went too far, you know? I did not. I was thinking about this issue here. I was really thinking about it. This is more like factorizing these things, you know? Could we use that? Perhaps not. But let's see if this one can help us, folks. Yeah, let's take the identity and see if it will help. So as you can see, once you forget, wow, guys, these ones are going to be negative, not positive now. Okay, these ones are going to be negative, not positive. So let's see if it helps us. Can you see? We take things and create things because you know what, and is kumbuli kahle lezinto. So this is just a reminder of what to do. So we know that perhaps we should take this guy down, this one up as a reminder. We are solving the problem here. So this is equal to. So let me see. What you will see, now you will appreciate, guys, this is nothing but the sum of two cubes. Okay, one is a cube over m cubed, so that's a cube, and that's a cube. So the way we want to do this, we want to say, okay, fine, we take the cube root of the first one. So this is going to be m plus 1 over m, like this. And then we cube it, minus. We come here. What is this? Yes, minus 3a squared. So this is basically going to be 3m squared times the other one. How is our b going? Times 1 over m squared. Okay, let's see this. It's going to be basically 3m squared over m cubed, because that's our b over there. I'm feeling the pressure now. So this is going to be 1 minus 3a squared. So this is going to be m squared over b, which is going to be m cubed again. I'm feeling like kuphindeka into yi-1 up. identity yami theni ngathi ngiqhela kabi yobaningi ka re ntlwaela hampe jwale okay guys, let's finish. Actually we are done over here now. So we go on and say, what was this? K cubed minus 3 over m minus 3 over m. I think the potile what I sense I should not have m. The m's have to go. What did I do? Okay. That is Kalwagagbi. Let's try another technique. I think I remember but I the identity, guys. But let's try. This identity says we'll have the cube root plus the cube root over here. Ne? And then here, this one must be a trinomial. So we will then say this is m squared. Right? So this is m squared. This was supposed to be a squared, so that should have been m squared. But anyway, we square this one, and then we want to get to this one too, so this is going to be plus 1 over m. Right? But for us to get cubed, it must be squared too. Right? Now we decide what happens in between. Now what we know is the rule, folks. We then subtract the product of these two. So let's see. We then say minus this one, when you multiply the two together, it's going to be basically m times 1 over m. This one goes, it becomes minus 1. Let's see if it goes back. If it doesn't go back, then it means we made a mistake. Let's go for it. M times m squared is going to be m cubed. And then we get minus m plus 1, m over m squared. Plus, this one is going to be m squared over m minus 1 over m plus 1 over m cubed. Now let's see what happens here. This one takes that. This one is taken by that. So m takes m. 1 over m takes 1 over m. So indeed we get m cubed plus 1 over m cubed. So yeah, this is good. So the rule here says to factorize this, if you want to call it a factorization or an identity, we take the cube root of what we have, take the sign, take the cube root. Here we then ask what must we multiply this by to get that. Get m squared, and what we multiply this by to get this, we write that. Now the middle term, we just subtract, the product of these two. So this works, at least. So as you can see, guys, sometimes the rule can come, it may not come. I start to feel like our identity, we didn't do a good job. There was something that we needed to do before I carried on. Yeah, actually now I'm thinking I went too far, because remember, a plus b all cubed is going to be a plus b right into this one and that one. And now when we solve this, we're going to keep this one a plus b. Then when we sort this out, what we end up with is going to be a squared plus 2ab plus b squared. I'm feeling like, it really didn't do what I want. It really didn't do what I want. I'm trying to think about it. Okay. Look, folks, the identity looks like it's not built this way because it's not giving me what I want. But I think the rule as I remember it has worked, so let's forget about it. But ponder upon this. Sometimes when you create these things, you start to find the sense in them. But when you shy away from challenging yourself with them, then you end up in trouble. Let's see, we will put it to the test if it will work. Let's just continue this way. Now, folks, we can appreciate that this is k into, now we've got m squared plus 1 over m squared minus 1, right? So this is k. Now, what did we say was this above? 1 m squared plus 1 over m squared, we said is k squared minus 2. So we just simply substitute this one with k squared minus 2 from above minus 1. So what we end up with is k into k squared minus 3. Then we sort it out. K times k is going to be k cubed minus 3k. I probably was going to go into something like this. I'm not too sure, because I still feel that identity should work too. That identity should work too. Because yeah, I think the identity could work. The identity could work. But the problem is, by the construction, it doesn't give me what I wanted. Okay. Let's see. Let us see. Now I just want to explore what we were trying to create here. Would it give us what we want, or would it not? Let's see. Because I think it should give us what we want. Let me see if we can win. We can win here. So we've got a plus b all cubed equals. Now we fold this out, we get a cubed. Right? Then we're going to have plus 2 a squared b, right, plus ab squared, okay, then plus a squared b, plus 2ab squared plus b cubed. Now let's try and isolate these dudes. We're gonna have a cubed plus b cubed, so we are done with that. Now let's look at this one. This is 2a squared b plus a squared b, so this is plus 3a squared b, plus again 3ab squared. So this is what we have, And then of course we will have a cubed plus b cubed is going to be equal to, remember this is a plus b cubed, and then minus 3 a squared b plus, minus 3ab squared. Let's try to construct what we wanted in terms of this. So we were having m cubed plus 1 over m cubed. We want to say this is going to be m plus 1 over m all cubed, minus 3. Now this one is going to be the square version, right? Because once this is squared, so this is going to be 3m squared. B is 1 over b, so it's 1 over m, so like this, minus 3a, which is m, over m squared, like this. Let's see what happens. So this is nothing but k all cubed minus 3. Now this one takes that, so we get 3m, and this one takes that, it's minus 3 over m. Then if we decide to take 3 as the highest common factor, so this is k cubed minus 3, then we end up with m plus 1 over m. Then we've got k cubed minus 3, this is k. Yeah, it worked, guys. So whatever you do, be patient with yourself, you will get to an answer. But it taxes a bit. So obviously this is when we are solving. So as you can see, you forget the identity you created, but of course be careful when creating it, because sometimes, as you can see, I quickly made a mistake and it backfired. So this can be used from creating it here. Right. Anyway, guys, I just wanted to show you every technique that you can try when practicing to really get your mathematics as strong as possible. As you can see, if you remember the rules that are shorthand techniques, you quickly get to the solution. If you don't, you create a path. You follow it properly. Don't give up on it, as you saw me do. Follow it nicely. Don't give up. Run the race until the finish line. At the end of the day, we will have solutions. Swat it. Anyway, guys, how many marks would you score for this? Obviously, this is mark worthy. And then, the business. This is mark worthy, where we got it from. And of course the mark, I would say 3 marks for this. If you chose to do it this way, essentially this would be mark worthy, this would be mark worthy, and the final answer still 3 marks. Okay, so not a big deal after all. Anyway, guys, I just wanted to show you how to solve a mess, how to unentangle yourself, although you'll lose time. But of course, if you practice this now, this gives you a chance to okay, I'm feeling a bit dizzy now. This gives you a chance to then move quickly. Remember, when you practice, if you take time, you will definitely be quick in the exam, because you will see something you can recognize and you know exactly how to do it. If you approach it without fear, you win. What question was this? Question 5. Okay. Good, we are done. Now question 6 says, consider the following equation. K equals the square root of 3 over x plus 4 minus 1 over x. Now we've got some silly questions to handle. It says, for which value of values of x will k be non-real? Okay. Now when we have radicals, it means for this to be non-real, it means there must be a negative under the square root sign. But now if we look under the square root sign, we'll already appreciate that 3 is positive. So 3 is positive. There's no questions about it. So the beef with us here is that guy. So this means for this to be non-real, it means x plus 4 must be less than 0. So therefore this happens when x is less than minus 4. Nice and easy. Okay guys, these are very easy 2-mark questions usually, or even 1-mark questions. I would probably just give 1 mark here. B says, now don't confuse, guys. There's something I need you to know. Don't confuse non-real and undefined. Those are 2 different things. Undefined doesn't mean non-real, or vice versa. That I need you guys to know, because some of you may say, this is going to be non-real if we have, say for example, x is equal to 0. By considering the second fraction, this 1 over my... No, it's not the case, guys. Once you say undefined, it means there is a solution, but there's no definite one. It can be a lot of them or a few of them, but we cannot pinpoint them, okay? Usually, undefined means element of real numbers. I hope you understand that, because it can be any real value. Undefined means that. I hope we understand these things, guys. I'm telling you. Let me say it again. Note, folks. Let me say it again. Note, undefined does not mean non-real. Please don't confuse the 2. And non-real doesn't mean undefined. If we want to expand further on undefined, it means undefined means real. It's real. But we can't put a finger on one solution. This just means real multiple solutions. This is something you need to understand. These are real. They exist, guys. And they can be multiple. So if we're looking for x, you can just easily say x is an element of real numbers. When you say this, you're simply talking about undefined. Of course, with a pinch of salt, because I know I may be killed for saying this carelessly. I'm probably not getting the idea correctly myself. I'm not going to claim I'm a mathematician. But for me, undefined, when it comes to solving for a variable in an equation, it just simply means if this is x, it's an element of real numbers. Meaning, we don't have a specific solution. For example, you're looking for a root. Then we say this is undefined. It simply says every other solution there is could easily be the root, or they are all roots. Okay? I guess this is... But non-real means does not exist. Non-real, it means not in existence. In fact, the other way is to say this is imaginary. It's complex, bafethu. for those who know complex numbers. This is complex stuff. And complex is non-real. Okay, just remember that. Complex. Ndicela ukunifundisa i-maths bantwana besikolo. Aniyazi ndiyanibona, ndiyayazi futhi loo nto leyo. Ndifuna nizazi, surely this one is going to confuse you. Because I'm sure you'll be like, ithini nangoku le ngqo? Iyabhibhidla. Yeah, iyabhibhidla. Sike siyeke kanjalo. The next question says, for which values of x, again, we're looking for the values of x, will k be undefined? Can you see? Will k have lots and lots of solutions instead of a definite solution or a few definite solutions that we can pinpoint? This means it can carry any value that it is. Now, when will this be undefined? It's when we divide by 0. So now we've got two conditions for this. It's either when x plus 4 is equal to 0, or when x is equal to 0 for the second one. So we can say, therefore, this happens when x is minus 4 or when x is 0. Good. Good, good. So this is good, this is good. And of course, I can give an extra mark for that. You know what? To understand what is being asked. Because remember, undefined, anything that has a fraction, if the denominator is 0, that's when we say undefined. Meaning, lots of solutions can be considered instead of some specific ones. Or one specific solution in that matter. Okay, folks. I hope this is clear. If not, renale bothata, white, renale qakehi. Hey. Now solve for x if k is 0. See now, nice quadratic that you guys know how to deal with nicely. So see, so we know that if k is 0, this simply means our radical 3 divided by x plus 4 minus 1 over x is equal to 0, because that was k. Now all we need to do, we isolate the radical, isn't it? The radical must not be with the others. Entanglement. As near his so man. We put it, the x. And of course, guys, I'm just going to do it here, but you guys must do it in the next step. This is one step. Can't do two things in one step. But now, because of space and time, I'm not interested in suffering. Right, so we just simply cross multiply and do the things. So we get 3x squared. This would have come there, so we bring it back. It's going to be minus x minus 4 equal to 0. We're moving like, hey. Oh, now, guys, I don't know. I'm not feeling passionate at all. But hey, it is what it is. If we put the 4 here and the 1 here, we are good. Sign of the big and don't. Yeah, it is the 1. It is the 1. Therefore, x is equal to 4 over 3. Or x is equal to minus 1. Now, folks, we need to go and check these solutions, right? Yes, first we need to be sure that there's no negative under the square root, because then that becomes non-real, meaning imaginary. Whew. Interesting, isn't it? Undefined, it means it's real but not clearly defined. I hope you understand these things, guys. I'm going to say them again and again until you get it. Now let's see, folks. what happens when we do these things? So we've got 3 divided by, now this is 4 over 3 plus 4. So minus 1 over 4 over 3. Whew. Yes, it's 0. So the left-hand side equals the right-hand side. So we are good. What about minus 1? So this is already going to be 3 divided by 3. That's 1. Square root of 1 is 1. Then we get here minus 1 divided by minus 1. That's going to be plus 1. 1 plus 1 is 2. 2 is not equal to 0. So this solution must be struck. Nice and easy. We get our second mark. Okay, guys, that's it. That's it. Of course, usually for the technique, we can give you an extra mark there. And then, of course, for factorizations, this would be worth 4 marks. Okay. So, guys, we're going nicely. We're going nicely. So we've done it, folks. You know, yeah, let me drink something. Yo, nkatele, nikarele sweswi. Yeah. Okay, guys, so this is essentially the end of that question 6. Let's quickly rush through question 7. This time I'm going to try and just get to the matter at hand. Of course, folks, if you're interested in this, I try to write it as neatly as possible, trying to give you as much as I can, and I hope you will watch this video until the end. I know you guys are lazy. You want 50-minute videos that have all these 10 questions. I can do it, but of what use is it to just show you what I can do instead of teaching you? I need to show you so that you can perform. I'm not supposed to perform, but to teach, it's my choice. Anyway, forget it if you don't get it. 7 says consider P over another rational expression or equation or function. Prove that P over this thing is greater than 0 if P is an element of natural numbers, meaning positive integers. Folks, it helps to know the implication. What do we mean by natural numbers? We mean positive integers. These symbols must not be foreign language to you. So this means CT. And then X is an element of all real numbers. Now, real numbers, we know it's everything that is a number except complex numbers, right? Right. So meaning X can take any value, negative, positive, 0, decimals, no decimals, integers, you name them. We need to prove now that this whole shenanigan is greater than 0, meaning it's positive in its entirety. When P is a natural number, meaning a positive integer already on the numerator, and that X can take any value that is in existence. So how are we going to do this? Now, folks, we just do it. So 7.1, we've got P over 4x squared plus 12x plus 13. Now, the best way to do this, guys, because we cannot tell whether this is positive or not for all real values of x, because we already know that P is positive, so we are already happy with P. But now the quadratic in the denominator is our concern. Now, the only way we can know what direction this quadratic takes is if we complete a square. Because we know that this is a quadratic where a is greater than 0. Now, if it is greater than 0, it means it is a smiling parabola. So this means it has a minimum value at the turning point. Now, if this minimum value comes up positive, for example, then we can say indeed this whole expression will be positive, because we already know that the numerator is positive. Now the question is, the denominator has a minimum value. Now, of what character is that minimum value? Is it positive or not? And if we can prove that this is a positive minimum value, it means for that expression, no matter what x value we put, we'll always get a positive answer. Only then we can make the deduction that this is going to be positive for all real values of x, and p an element of natural numbers. So we know that this is equal to p, which is positive, divided by, we complete the square. Now remember, when we complete the square, we first factorize this thing by taking out this then we end up with, maybe let's do it this way. It's going to be x squared plus 12 divided by 4 is 3x, then plus 13 over 4. Okay, so we must do it so that we can return it back if we need to. So this is p over, now we do the things. So this is 4 into, take what is under the square, we have the coefficient of x, then we square the whole thing, plus 13 over 4, then we immediately minus 3 over 2 all squared. Please guys, be familiar with these techniques. Know how to complete a square within an expression instead of an equation, because sometimes this is a very good skill, as you can see here. Comes in very handy. Now all we do, folks, we just clean it up a bit for just one more moment. Now let's see, this is 13 over 4, this is going to be 9 over 2, this is 4,5, this should be bigger than that, so this should be positive. But I don't want to think now, let's just go for it. 13 over 4 minus into 3 over 2 all squared. So this gives us just one. Now we go on and do the things. We must write it, guys, in standard form. Now this one, we redistribute the 4, is going to be 4 into x plus 3 over 2 all squared plus 4. Okay, now we can tell that, we know for a fact that this is a perfect square. So this means this thing is either 0. What we have here, it means this thing is greater than or equal to 0, right? And if we're talking minimum, because this is a smiling parabola, what is the smallest value that the perfect square can take is 0. So when this is 0, therefore the minimum is going to be 4. That's the y value at the turning point. So now we can clearly see, guys, that if the minimum value of this expression is positive for all real x values, then it means this thing is always going to be positive. It's one of those graphs that actually don't touch the x-axis. It's a graph like this. Of course, where will the turning point be? The left-hand side. So this is a graph like this. You know? Appreciate these things. So can you see, this is telling us that this is at 4. So this parabola, if it never touches the x-axis, can you see everything is positive? So this means no matter what x value we put here, we'll always get a positive answer. So now in this case, seeing that the minimum value of this graph is positive, it simply tells us that now we can make the conclusion that you can say, therefore, P over x 4x squared plus 12x plus 13 is greater than 0. Or maybe let's start here. We can say, therefore, we know that 4 into x plus 3 over 2 all squared plus 4 is positive for x, for all x, an element of real numbers. You can say, therefore, p over 4x squared plus 12x plus 13 is greater than 0 for all p, an element of natural numbers, and x, an element of all real numbers. Nice and easy. Okay guys, so that's how we do this, because we know that this is going to be positive, since we know that the smallest value it is taking is a positive number. If this graph takes a positive smallest value, then no matter what x values we're going to put there, that's the case. And we know that natural numbers are positive integers, so that's why we don't have to bother with that. So as you can see guys, this looks impossible, but it's a very, 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 very simple little thingy there. So this is the graph of that quadratic. So let's see how many marks we're gonna get here. First and foremost, for writing this one in standard form or vertex form, this is a mark. Remember, you are told in grade 12 and 11 that maybe grade 12, you are told that completing the square is not technically examinable, they say, but in essence they're lying, because look at the questions that have needed this. But it simply says, look, we don't care about the steps, but we care about the outcome. So that's what we get. And for stating that this is positive and then making the conclusion. So this was just an easy 3-mark question, but it looked as if it's not. Okay guys, hope you're good. Next one says, determine in terms of p the maximum value. This one is easy, so we can squeeze it here. 7.2. Determine in terms of p the maximum value of this guy, if this is the case. So what did we say? Maximum, it means the denominator must be the smallest thing. P is a constant, so to speak. In this case, we don't consider it a variable. A variable in algebra for your level is the x and y. Okay, so essentially this means the denominator must be the minimum. So we know that this is just going to be p over 4. Okay, so we take the minimum value of the denominator and the maximum value of the numerator, and the maximum is whatever value p is, because it's a constant. So again, this is just a 1-mark question guys, nothing really serious. 7.3 says, find the x value that gives this a maximum value. Right, so what is it? It's that one, the axis of symmetry. It's what is under the square. We equate it to 0, so we know that x is going to be minus 3 over 2. Again, easy 2 marks over there. Of course, these questions are scaffolded. When they are not, it could be more than that. Okay, remember, if we can just decide to not ask all these other questions and just say, given p over 4x squared plus 12x plus 13, what is the x value that gives that expression a maximum value? So obviously we know that we're looking for the minimum value, then we look for the x value that gives us the minimum, and that's it. But of course, here, what did we do here? you simply take what is under the square, x minus, x plus 3 over 2, you equate to 0, and then solve. So that's just what we did there, in case you are confused. Now, folks, this is how algebra, in my opinion, should be examined. Otherwise, this nonsense, you being asked how to solve for x in grade 10, even grade 9, grade 10, grade 11, grade 12, and then you pass with distinction, and then we say, yeah, you are smart. No, you are not. I'm sorry to tell you that. You are just, you're lucky. I'm joking, guys. Sengiphaphile. Se ke phapha jwale, e re pele ba nthesele. Ke itholele ngwana motho. Ke ijele papa ya ka molomo wa ka o moholo wona. Le leleme le letelele ka re ke la eng. Ke la giraffe, ke tsebe. Ke eng na le leleme le letelele. Ha ke le njwetseng bana beso. Diqeleleni kaloku. Tell the brother. Now, folks, we're getting to question 8. Now, this is more of the usual stuff. Okay, guys, I'm going to try to move quick now. I'm not going to toy with you guys. There's like 2 more questions to go. And then we finish this algebra course. Let's just do it. Let's just do it, guys. You'll never find this put together nicely like this. And you learn in the process. So 8.1, we're solving for x. This is the usual language. Now let's see, this is the log of x to the base a half. Please don't say log base half of x. No, it's a log of a number to a base. Read expressions properly. Log of x to the base. It's an inverse of an exponential expression where we start with the base to the exponent. This time we start with what would have been likely an exponent, or should we say the value, because this is the value basically. Remember, a power is the value of an exponential expression. So this is more like it. Now we are told that this is less than 1 and we need to solve for x. Wow, how do we do that? Well, we convert to exponents. So this implies that our x is going to be greater than base half to the exponent 1. So therefore x is greater than 1 over 2. At this point, x is an element of real numbers. Nobody cares. The inequality itself says it all. Now you may be wondering, how did I know I have to change the sign when I convert to exponential? Now, folks, this is the secret for you to find out. But all I can tell you is that when a log of any number is to a negative base, is to a fraction or a proper fraction of a base, it already tells you that this is a decreasing function. And if this is the case, we know that the log of any number to a base that small. Did I say any number? Hold your horses, brother. But that thing is negative. It is negative. How do I know? I know it. Because remember, if I was to draw the graph of this function, guys, the graph of this function, please, you've learned functions now. Do not be complacent. If you do become complacent, please come to me. Izobulala, because I like people who are complacent. Now this is a non-shifted BSF 80, so you don't need a diaper. Okay, I said less than 1. Okay, that's fine. Not a big deal. Now we draw this graph. We know that this graph would move something like this. Right? Yes. And where does it cut? At 1. But when will it be 1? When the number is the same as the base. So if the base is a half, it means this would be a half. Then it would register 1. Can you see when is it less than 1? All of this region from 1 going all the way to Jerusalem. We can appreciate that all this region after a half. Can you see why x must be greater than a half? Because it can't be less than a half. So graphically, we can prove that this is nonsense if you were not to change the sign. But now I want you guys to know, when did I know, besides the functions? Let's say you were doing grade 11 and you happened to know about logs. So how would you justify this? Let me show you. Now folks, we use the laws of logs. So we're going to say log of x to the base a half less than 1 means we have log of x to the base 10 divided by log of, like this, ne? We are saying less than 1 over 1, of course. Now folks, what are we gonna do about it? Yes, we're gonna do the right thing, because we know the sign log of any number that is less than 1 but greater than 0 is a negative number. You can check it on the calculator. Now that we know that this is always negative, we can cross multiply only when we know the sign of the other expression, or should we say variable. If we don't know the sign, don't cross multiply. But once you know the sign, you can cross multiply. So when we multiply this by 1, we know that log of x is going to be, multiplying by negative, the sign changes. It's going to be log of a half. Now we just drop the log. So that means x is greater than 1 over 2. Now you know the maths. You must go and do it. This is an alternative approach, by the way, using log rules. But once you know the sign of what could be easily a variable, you run with it. The only issue would be, how would you know that log of x is not negative? How do you know? Why do I know this? Because now there's a very good question of saying, what if the sign changed when you cross multiplied with this, but what if this is also negative or has a potential? We know that this can never be negative. Okay, this will never be negative, because this whole shenanigan cannot be negative. Why I know it is only because any log of a variable to a positive base that is greater than 1, when we don't write it, it's a base 10. Now base 10 means, yikes, is the 1, okay? Is the 1. Okay guys, so yeah, okay, maybe I lied, maybe I didn't lie, I don't know, I don't care. I feel like that thing has a potential to be negative, because we know that log of x can be both negative and positive, you see. Now this makes me uncomfortable, you know. This makes me uncomfortable, because I feel like I cheated. But anyway, let me just say to you guys, the one thing that we need to know is that when we cross multiply, we focus on the signs of the denominators. They are literally the ones cross multiplying instead of the numerators. Let's just leave it at that. I think that's essentially the whole idea. I may be wrong about this. Please verify this, folks, in your books, whatever, internet, check, ask your teachers, your tutors, your university friends. They can tell you. But if I solved it and it works, I'm happy. The graph also proved it. Okay, guys, I'm slowing down, and yet I wanted to speed up. So how many marks would a student get for this? Of course, for the change of sign and for the answer. Easy, 2 marks. If you decided to use log rules, this would probably be a mark when the sign changes and when you drop the logs. Nice and easy. Now let's get to the next question. 8.2. We've got this nice expression, x minus 1 all cubed equals x minus 1. Okay, so what are we doing here? Well, we're going to let something be equal to k. Let x minus 1 equals k. We don't want a complex situation here. No, man. So this implies that we've got k cubed equals k. So k cubed minus k is equal to 0. Okay, maybe I'm taking it too easy. Let me write neatly. K cubed minus k is equal to 0. Highest common factor is k. We get k squared minus 1 equal to 0. We can say therefore k is going to be 0, or k squared is equal to 1. All right. Therefore k is equal to 0, or k is going to be equal to plus or minus 1. But now we know what this implies. It means x minus 1 is equal to 0, or x minus 1 is equal to plus or minus 1. Therefore x is 1, or x is, and let's say it's a positive 1, it becomes a 2, or x is, we say negative 1, this becomes a 0. Now, does it balance the equation? Yes, it's a cubic, so we expect 3x values at least. So if we put a 1 in there, this whole thing becomes 0. We put a 1 there, it's 0, so left hand side equals the right hand side. Good. Put a 2 there, 2 minus 1 is 1. 1 cubed is 1. Put a 2 there, 2 minus 1 is 1, so left hand side is equal to the right hand side. Put a 0 there, this is minus 1, cubed is minus 1. Put a 0. Minus 1 is minus 1. So all these solutions are good. So of course, guys, I did not need to explain this, but it's very key. I think this is good. And how many marks? 1, 2, 3, 4, 5. Okay, we can be generous if we want. Otherwise, a careless student would want to expand and suffer. But you guys should already know how to solve cubic expressions by term 2. So that means those who are writing the May June exams have no excuse if they have to do it. But as you can see, the K method makes life easy here. Okay, so these are solutions. Please underline the solutions like this to show that you have stopped working. If you leave them hanging, we don't know if you're finished or you're still coming back, okay? Don't confuse us. Don't confuse us, comrade. Now let's look at 8.3. We've got x over 2 less than or equal to 2 divided by x. Now we're solving for x. Now remember, x in this case, remember, focus on the ones in the denominator. We know that 2 is a positive number, so that's good. But when we cross multiply x, x can be both positive and negative, so it's not allowed to cross multiply. Do not, when the variable in the denominator, you cannot tell the sign or the expression. So we write it in standard form. So this is x over 2. We transpose. This has become 2 over x less than or equal to 0. Now, what we need to do, we need to create a single term. We can't deal with two terms like this. So when we create a single term, the common denominator here is going to be 2x. Then when we do this, we get x squared, right? Then when you do that, we get minus 4 less than or equal to 0. And you know most what is happening here. This is a difference of 2 squares. So this is going to be x plus 2 into x minus 2 all over 2x less than or equal to 0. Now, technically, these kinds of inequalities, the table method is the best method to handle issues here. So we've got x plus 2, x minus 2, 2x. And of course, okay, let's do it elsewhere instead. So we've got here x plus 2, x minus 2, 2x. The table method is best for these kinds of inequalities. Avoid the graphical method if you can. Yes, there's a way of just carelessly doing it, but don't do it. Don't do it like that. It's dangerous. Right. So we've got 3x values this time around. Now, when we say critical values, we just take each one of the factors we equate to 0. So we're going to have a 0 somewhere for the denominator. This is going to be minus 2. This is going to be 2. So we've got minus 2, 0, and 2. We must always list these in ascending order. So we're doing a division overall. Now we start. When will this one be 0? When x is minus 2. What happens when we put a value greater than minus 2 but less than 0? Well, this would be positive. When we put 0, it stays positive. When we put a value between 0 and 2, still positive. Then we put a 2 there, it still remains positive, a value greater than 2. If one side is positive for a binomial and there's a 0, the other side should be negative. But you can check it if you're not sure. The second factor would be 0 when x is 2. When we put a value greater than 2, this is positive, so it should be negative all the way from there. Right, this one is going to be 0 when x is 0. It's going to be positive all the way this side. It's going to be negative all the way that side. Can you see, guys? This is so easy to do. Now, first of all, we say these two multiplying together. This is a product. And then whatever that is, we then divide into the denominator. Okay, so don't forget this. So, what are you doing now? Let's get this done. So we've got negative times negative, that's positive. Positive overall divided by negative is negative. 0 times any number is 0, and 0 divided by any number is 0. Positive times negative is negative. Negative divided by negative is positive. Positive times negative is negative. Negative divided by 0 is undefined. Okay? Positive times negative is negative. Negative divided by positive is negative. Positive times 0 is 0. 0 divided by any number is 0. Now this one is going to be positive. So what are we looking for? This must be less than or equal to 0. So 0 is included here. And it's included. But this one is undefined, so we may not include it. And then, when is it negative between the two? And where else? 0 here. Is it included? Yeah. And in which direction do we go? That direction. So how do we write the solutions here? You can say therefore x must be less than or equal to minus 2, or x must be less than or equal to 2 but greater than 0. 0 cannot be included. I'm hoping you guys are learning something here. Of course, I don't have space to write. X must be an element of real numbers in each case. Either way, this is how we get to the solutions, guys. Nice and easy. Nice and easy. X cannot be equal to 0 because we would have an undefined situation, okay, where all values of x can be considered, and usually these kinds of expressions are not those kind where. All right, that's it, folks. We get it done. Of course, you can draw the graphs and work on the graphs, but that's a business of functions. So in functions, we do ask this, f of x, if we choose that the numerator is f of x. So in functions, this very exercise in algebra can be asked as in f of x divided by, say, g of x. We say less than or equal to 0. It's the same thing. So this is essentially the algebraic way of solving. But you can still bring in the function way of solving, where you can draw the two graphs, then analyze the y values as they divide each other, and then get the solutions. Right. So I prefer both techniques of doing a graph and essentially using the table method. But yeah, for the sake of this business of ours here, let's not do that. Okay, let's not do that. But hey, why not? You know what, students? When I am arming you with everything, just take it, okay? Don't ask questions. So we know that this is a parabola that has a negative y-intercept. But now where will be the axis of symmetry? Well, the axis of symmetry here is where? Tell us. Is exactly on the y-axis, because this becomes the minimum value, -4. So this graph is doing stuff like this. Okay. Right, so we know that this is going to be -2, this is going to be 2, and then this one is a graph that passes through the origin, but it's fairly steep, then y is equal to x. So that's what we have, guys. So now, when you look at these two graphs for analysis purposes, because we need to solve the problem, because this is the origin. Now, when we analyze these, what do we want? F of x, we can call this one f, then we can call this one g if we want. This is when we are considering functions as a way of solving this problem. Of course, this one here is -4. Right. Now, let's look at this and establish some things. We want this to be negative, so this can happen. This can happen when the numerator is 0, right? So this means here, when this one is 0, this is possible, right? And when this one is 0, again, the parabola must be 0 for the graph to be equal to 0, okay? Pay attention. This one is a bit tricky when you're solving it this way, especially this one. That's why I prefer the table method. But if you look at it, you will see that essentially this graph you will appreciate that. Okay, I just want visible colors. You will see that this straight line is 0 there, and then it's negative elsewhere. But this one is positive. Can you see? And it's 0 over there. Right? Now, if you look at these solutions, you will clearly see that this part, all these x values, essentially give us a quotient that is negative and 0 right on the line. So can you see, this is when we say x less than or equal to 2. So this is good. This is good. And then we look again and say, where else do we see this? When is that? Well, if we look at it again, we will see that when can this be negative again? This is when this is positive and that is negative, isn't it? So when is that? We see that this is what happens over here. Between the two here. Now that region, when we look at it, we will appreciate that this dude is positive, the parabola is negative. And of course, when they are both 0, this is undefined, so especially the denominator, when that is 0. So this line is not defined. So this is that part where we have to get rid of that. Otherwise, on the other side, they are positive. So that's not what we want. So what we want is this one as well. So I hope you guys, as very silly as I am doing this, you can actually draw the graphs, analyze the graphs, and find the solutions. As long as you draw perfect sketches. And you can do this without wasting time. For x-intercepts, this is the case. You need to do this like a pro. In grade 12, we don't care about basics of grade 10. Please. Yes, we want them when we do need them. But we don't really want them to come out, that crazy way. Anyway, folks, let's get to 8.4. This time I'm not going to mark that one. It's an absolute waste of time. But all I can tell you is that this is mark worthy. And the solutions. Okay, 3 marks. We did it. Right, now the next one says, or the last one here, we've got 5 to the exponent 2014 minus 5 to the exponent 2012, all divided by 25 to the exponent 1006. This is to be equal to 24 times, remember a dot in maths is a multiplication, 5 to the exponent x minus 1. Now we need to solve for x, and the key is that we must not use a calculator. Obviously, if you do this on the calculator, it will already tell you undefined. Because once you say 5 to the exponent 2014, that's already evaluating infinity, and infinity is undefined. We don't know where it is, but we know it's far away, but we can't pinpoint exactly. Do you understand now when we say undefined? We don't mean non-real. It's there somewhere, but we can't place it. That's just the thing. So obviously the calculator will refuse to evaluate this. So you think there's no solution, but there's actually a solution. Now we go on and use our rules. Now we can see there's nothing we can do about the numerators at this stage. But the other thing that I can tell you for free, anyway, let's just go for it and say 2 to the exponent 2014. Not 2, but 5. See, talking too much is not good. 5 to the exponent 2012, all divided by, we first change this one. This is going to be 5 squared. Now 2 times 1 is going to be 20. 2 times 0, 0 again. 6 is 12. 1 comes in front. So this is good. Equals 24 times 5 to the exponent x minus 1. Nice. Now we can see that, this dude is coming up nicely. So this means we need to do something about u. But the key is that we want 2012 so that we can take out the highest common factor. So this is 5 to the 2012 times 5. Now if we want to 4 there, this must be 5 squared. Minus 5 to the 2012, all divided by 5 to the 2012 equals 24 times 5 to the x minus 1. Now we factorize by taking out the highest common factor. 5 to the 2012 into 5 squared minus 1, all divided by 5 to the 2012 equals 24 times 5 to the x minus 1. Then we take this dude from that. Nice and easy. So we've got 5 squared, this is 25 minus 1, this is 24, equals 24 times 5 to the x minus 1. Now these ones will divide nicely. And then what we end up with 5 to the x minus 1 is equal to 1. Remember, when this is divided, it gives us 1. Now exponential rules, 5 to the x minus 1 is going to be 5 to the 0. Then further, we know that x minus 1 is 0. Therefore, x is 1. Nice and easy. So of course, guys, with these kinds of questions, please don't just move. Check. Left hand side is equal to the right hand side. Please. You can't leave this question wrong. These are free marks. Once you see these kinds of questions, you know these are free marks. Although there may be some work for you to do, because they're not very straightforward, of course, but these are the solutions that you cannot get wrong. And submit this to your teacher, unless you are saying to the teacher, I know focal. If you don't know focal, then you must forsake from that classroom, okay? Or else I'm going to clap the hell out of you. You're gonna go home with your eyes closed because of swelling, bruises and all. And if your parents come, and I'm gonna kick them with you again, you're all gonna go home not able to see nothing. Alright? So do not challenge me. I'm dangerous. You know where I'm from. I'm from the Cape. Yes. I don't play. Alright, guys. That's the thing. That's the thing. Check to be sure. Now let's go back and check. If we say x is literally, holy cross, 1. Hey, but this check is not going to be nice, eh? It's not going to be nice. But anyway, I think the check, hoping that we did well. This is the best place to go and check. Of course, you can see this is a bit peculiar. Remember here, it has to be right. That means all the steps above it must be good, because we cannot evaluate that on the calculator. Now, when we put it there, we will see that this is going to be 5 to the 0, which is as good as 1. So this can give us some idea. But this is shaky ground, please. If the steps above it are not correct, this is bad. So this is shaky ground. But hey, you use everything that you can, guys, to ascertain that you are not far from the truth, okay? Yes, the answer may be perfect to that, but if it is wrong, then it's wrong. But at least you can't have a situation that disagrees with what is immediately in front of you, and you expect us to take that. I mean, if I see a paper like this, if I was a teacher, I would tear that thing apart and give you 0. I don't care if you did well with the others, you get 0. Because you cannot tell me as a math student, you cannot do this. These are the kinds of questions that should decide if a student passes or fails an exam, despite the mark that they got overall. You know, at medical school, for those of you going to join, there are some questions that are failing questions, irrespective of how well you did in the others. You'll be given perhaps a series of 10 questions in a series of 10 stations. But if you get to a station where there's a question that we cannot negotiate, a fail, because if you fail that station, it means you're not supposed to become a doctor. We don't care what excuses you have for yourself. We have plenty of hours as well not to pass you. So don't blame us and say we are cruel. No, you are the one who's silly. So usually usually even distinction candidates are seen from those kinds of questions. If they excel on the past questions, even if they struggled elsewhere, they are given a chance to compete for a distinction. That means taking an extra exam. At varsity in the clinical years, if you're doing medicine, you don't get a distinction by scoring a straight A in the written exam. No. You get a distinction by going to a clinical oral examination. That is extra to the one that is part of the exam. The exam is in two components. You do the written and you do the oral. But for you to get a distinction, you get an extra oral, because now there you are given distinction questions. And if you pass them, then you deserve one. We can't just give it to you because you went and crammed and saw the question papers beforehand. You wrote the written, you got 90%, and then you come, you crammed all the cases in the wards, and you know exactly what conditions they are. You read around those conditions. You come here and you think, I'm going to be impressed. No. But you see, the problem with me, though, I'm one of those people who can actually help you hang yourself, even when you are better prepared. Because I know a person who knows and understands, and a person who just knows for the sake of flexing. And I don't like those ones. I want the ones who know because they do know. Because even when you give them a rope, they don't hang themselves. Instead, they snap that damn rope. Okay? All right, okay. Now, let's leave the nonsense. You know, almost when I start doing these things, it means I am losing it. Now, question 9. Arithmetic. Bafethu algebra yodwa. Never. Arithmetic so. Simplify the following expression without the use of a calculator. The calculator. Now, how am I going to do this, guys? Look, first thing, if you look, remember, always inspect. If you look, this is a radical or a square root of two terms underneath it. Even there's an extra square root. So there are no rules or laws that you can apply for this kind of shenanigan. And this one too. So don't even attempt to use rules. Don't even try to think, because you're not thinking anything. You're just wasting time. You're goofing around. And we don't take that nicely. We do not take that kindly. We actually see tata ngolunya. Wabona? Ha re tle ka pelo e ntle jwale, re tla ka potlako empe hampe e kotsi ka ntwa ya ditjhaba, e seng mohlomong ntwa ya lefatshe. Ke a tseba ha ke shebile tjena ke bone hore hantle re shebane le ntwa ya lefatshe ya boraro ya tla. Hobaneng diketsahalo tsena ke bonang mona ka ntle ka mona, especially batho bana ba ipitsang di-president le di-politicians. Baetapele bana ba rata ho lwana, empa ntho ya bona ke hore ha ba kgone ho lwana. Bane ba tseba hantle hore ha ntwa e hlahella mona, e tlo ba bang batho ba tlo shwang. Ba ntse ba re ba e defend, hobane ba tseba hantle hore re tshwana hantle le dinku. Wa bona? Re etsa ntho ya rona ka motlotlo, empa ke motlotlo o kobeileng, o sothileng, o shebile morao kwana. Wa bona? Wa bona di ntena hampe ntho tsena. Because hey, if you didn't hear this one I just said, you know, World War III is like on the way, Buffett. And this World War III is because of these people they call leaders. Of course, people love them because they seem to sing a song that they want to sing. Of course, selfishly so, because people are inconsiderate. I don't care how passionate they are. They are just foolish. They don't deserve to live on this earth. But hey, whatever. I'm only saying what I say, but remember, I will never admit to that if you put me to task for it. In fact, I will deny it. So don't even try to hold me accountable to this one. It's not going to work. Anyway, folks, how do we solve this now? We know that there are no damn rules. So, students, do you want to indulge? Maybe I should leave it for you. Anyway, folks, let's not waste time. Now, there's a few tricks that you can consider. Remember, 4 over 4 could very well be expressed as 4 root 7 over root 7. Because remember, this is 1. So this could be very well the same thing. So try these tricks. But even if we try this, it just transfers the root to the 4. Then it creates a denominator that we may not be able to get rid of, and we still end up with terms under the square root. So doesn't really seem to work. So sometimes these things, guys, that will cause trouble. So you can multiply by 1. You can try to change this. Root 7 essentially came from the 4th root of 49, for example. But again, this doesn't help us, So all of these things, that you can already see there's some difference of 2 squares trying to come up. So look ahead sometimes. Don't look in front of you. Sometimes you look ahead and be like, difference of 2 squares. But how will we get there? When we multiply the 2 radicals. But what would make us multiply the radicals? Well, if we choose to. But remember, we cannot do that. Even the so-called squaring, you can't just square here. What would be the motivation for that? Absolute nonsense. You can't square directly like this. But this is already giving us the vibes that perhaps that can work. But now, what did I teach you? If you can't solve it directly, name it something. So we can just say, let this thing. And you see, we're going to solve arithmetic algebraically now. I'm telling you. How do you say you're telling in Afrikaans? Yeah. Whatever that is, we let this guy be K. Indirect solving. Because these are very silly questions. You will spend time thinking and cracking your skull. But yes, sometimes you don't know what is best when you see it. Try everything, but the moment you realize you're out of ideas, try naming it, nomancane xa ifika umazi uba uzoba yintoni. Uzoba sisigebenga lo mntwana, uzoba ngumfundisi, uzoba sisidenge nje sihambe sivuze imifinya apha phandle, uzotshaya inyawo be. Is this kid going to be useful? Is it going to be wonderful? You don't know, but you just give a name. And this time you're going to give a nice name. You're not going to give a bad name, are you? No. You give a nice name. And then once you give a nice name, you know what? The kid can be channeled into the right path. You can start to understand the kid if they are against the name or for the name. But before then, you would not know. Anyway, so name this guy something. Now this implies, now in the next step, guys, we do the gymnastics. Now once we have an equation, 4 plus square root 7 minus root 4 minus root 7 equals K. In this step, only now we can do the things, because what you do on the left-hand side, we can do on the right-hand side, because we are literally not changing the relationship. See? Critical thinking bafethu. Now once we do this, we expand the bracket. So when we do this, this one just comes up nicely. This is what we get. And then we multiply this with this one. Guess what? The root is going to be the laws of surds. That means we multiply what is inside under the main square root. But of course, this sign will prevail. So this is going to be minus the root of, we're going to have 4 plus root 7 into 4 minus root 7. I'm moving quick, guys, so oops. If you don't follow, you're going to tshwarela me. So this is going to be minus, and of course that comes up when we square that last part. So it's going to be 4 minus root 7. And then we're going to say equal to K squared. Whew. Right, we go on. So this is 4 plus root 7. And then we got minus Now when we sort this out, this is the difference of two squares. So this is 16 minus 7 minus 4 plus root 7. Eh? Hey, this one is positive. Here when trompolaisha when man trompolaisha when. Remember, when you square this thing, it's going to be positive. So this one is going to be positive 4 minus root 7 equals k squared. Now we have things that are going to take place. This guy takes that, and then this guy, and that adds up nicely. 4 plus 4 is 8. And then we've got 16 minus 7, that's 9. Square root of 9 is 3. So this is minus 3 equals k squared. 8 minus 3. Eh? What am I saying? Eh, man, urauri. Hey man, there was supposed to be a 2, man. Remember, these things are gonna be 2. Oh God, you see now. I'm seeing things that I don't understand. You see, guys. I can see that man, something is missing. You see, always skeptical. Don't accept nonsense, even if it's from you. You know that this is gonna be 2, right? Because you know, almost when you've got a minus b all squared, right? These ones are gonna be 2. Yeah man. So let's start again. So we're gonna end up with 4 plus root 7 minus 2 root. This is gonna be 16 minus 7 plus 4 minus root 7 equals k squared. And of course this still happens, nothing changes. 4 plus 4 is 8 minus 2 into the root of 9, this is 3, equals k squared. So this implies that this is 8 minus 6, so this is 2, it means k squared is equal to 2. Now we do the gymnastic algebra stuff. So therefore this implies that k is going to be plus or minus 2. Now the question is, are these answers both okay? Remember what k is. K is this expression. So now we have simplified it. No. This is plus minus the square root of 2. Oh, because I'm sleeping. Anyway, I've been talking for so long, folks. For 3 hours. Huh? Yeah, man, that's a lot. Now, folks, we've got k equals plus or minus the square root of 2. But now, is it possible that this is the case? Now, remember, we're told not to use a calculator. Now, we can just put it on the calculator and see if both solutions, are correct. So we just say square root 4 plus root 7 minus the square root 4 minus the square root of 7. Just put this one. Gives us a positive 1,414. What? Okay, we get 1,414213562. Let's see. This is positive. So now let's take the square root of 2 and see if it is the same answer. 100%. So it's the same answer. So this thing is the same as the square root 2. But remember, only the positive. So now we can make an answer and say, therefore, k is equal to the square root of 2. Right. Now we have simplified that expression because we know what k is the very expression that we were supposed to simplify. So indirect ways of solving, as I said, if you want a friend of your, you want a friend of your friend, You talk to your friend, they connect to their friend, and you'll have them if you want. So essentially, guys, yeah, hey, imaths izokubulala ingqondo. Zofa fi, utloshwa. Right, for naming things, remember when you don't know what it is, you give it a name, then you can judge whether it follows the name or not. That's just how a child is. Of course, hoping that you're going to raise them well. The gymnastic is very key, right? Algebraic stuff. And then the expansion, we may give you a mark, we may not give you a mark, but I do think this is good over here, guys. Well, for your troubles expanding and, all the stuff, we can say, well, perhaps an extra mark, just so that we can be fair. Otherwise, there's no need for 4 marks. 3 marks is good enough for this question. It's not difficult, but it's a technical question. Now the last one for algebra, guys, for 3 hours. I got under. Now show that this has no real roots. Now nature of roots again, guys. As I said, if you want this document, you will find it. Now there's also some sequences and series questions that I would love for you guys to try. So download this document and look at these questions, especially these ones, these very first 3 questions. Yeah, these ones. Leave the others. Okay, I'm only gonna stop it there. I feel you will understand why I say algebra is important, because those questions are going to force the algebra out of you. Now, anyway, let's not go ahead too far. Too soon. So this is x to the exponent 4 plus 1 divided by x to the exponent 4 equals a half. Okay. So now we need to show that this thing has no real roots. Okay. So what do we do, folks? Yes, must cross multiply this thing. So this implies we're going to have 2x to the exponent 4 plus 2 is equal to x to the exponent 4. Bring everything to one side. We get 2x to the exponent. It's just going to be x to the exponent 4. Plus 2 is equal to 0. Now the only way we can solve is just transfer this thing, transpose it back. So now I'm starting to think, okay, let's not think, just go for it. X to the exponent 4 is equal to minus 2. Is that possible? No. An even exponent, even though the base can be negative, but an even exponent, whatever quality the base is, can never be negative. So this is not possible. Now this means there's no roots here. So we can say, therefore, there is no solution. This is another way of saying non-roots, non-real roots, or the roots are non-real. Right? Right. So the roots are non-real because we can't solve. Remember, the roots are the solutions. So we can't have an even root of a power. What can I say? An even order. Not root, but an even exponent. Even if the base is variable, it can never be negative. It's always positive. So that's nonsense already. So there's no solution. But of course, maybe the students who want, they can say we can take the 4th root here. And whatever we do on the one side, we must do on the other side before we say the things that we want to say. Let's follow the steps properly. Now we can clearly see that we're going to have x is equal to x is equal to the negative 2. Now, can you see this is non-real because we cannot take an even root. Now, this is what I wanted. We can't take an even root of a negative number. Or we can't have a negative number under an even root. You see? So this is it, guys. So very easy to say this. Yeah, that's the one, guys. That's the one. The other way that I can show you nicely quickly. So what you do here, you can say x to the 4 plus 1 over x to the 4. Now you can focus on this and say, okay, maybe this is equal to a half. Let's just do it. So this implies we can split the solution x to the 4 over x to the 4 plus 1 over x to the 4 is equal to a half. Now already this guy and that guy go away. Now we end up with just 1 plus 1 over x to the 4. This is equal to 1 over 2. Now if you look at this, guys, 1 over 2 is 0.5. But can you see here, no matter what is going on here, as I said, since this is an even exponent, so this is a fraction, we don't care what it is, but whatever we get here is always going to be greater than 1. Because it's 1 plus something. So can you see something greater than 1 cannot be equal to 0.5. So this is already suggesting that, therefore we know that 1 plus 1 over x to the 4 cannot be equal to a half. Because that is already greater than 1. And so you make the nice conclusion that therefore the roots are non-real. So there's many ways of killing a cat. If you kill it nicely, it dies, okay? But if you kill it in a hurry, it might kill you instead. Right. So anyway, guys, this is it for these 3 hours. I didn't think I was going to take 3 hours. I was hoping for just 1 hour, so 45 minutes. But I felt, you know what, there's a student who's probably writing the May, June exams and now already knows the routines, but needs a proper instruction. So I felt, let me show you these things so that when you get those silly questions, remember, what if in your May, June exams, if you can master that 1.4, 1.3 type question, what if you kill it? And maybe that would give you the mark that you want or drive you into a distinction. Because you can do well in other questions, but if you don't do well in that particular question, maybe it's there, who knows? And then you end up suffering and feeling like you just couldn't make it. So guys, I need you folks to not take these things for granted. I know I sound like a crazy person talking non-stop for 3 hours and whatever. But at the end of the day, you know what you should know. And of course, this video is going to be very long and crappy. But of course, a course, guys, if you're attending a course, you know you're going to spend a significant amount of the day just on that course. So here we're just doing an algebra worksheet, or should you call it a course. So you're going to have this memorandum of the algebra together with those questions nice and clean. I'm going to clean them up and essentially publish them in the description of this video so you can download for reference, because where I got these questions, you will not find the worked solutions, okay? So these are what you create by understanding maths. Some of them are my own creation, of course, or even a bit of a distortion of what I had because I didn't like the way those questions were asked. Because at the same time, I didn't want the questions to be leading. I wanted the student to know how to find their way, no matter what. Anyway, guys, leave a thumbs up, subscribe into the channel. There's plenty of videos for you here already that are nice and straight to the point. This is just, you know what metric is. These videos that are long, this is what metric is, guys. You sum everything up and put it together. Because in metric, we cannot expect you to solve for x in a straightforward quadratic equation where you can just look at the values and then know the factors. And yeah, even if you can eventually, but we have to give you a struggle, okay? I am liking the way the Gauteng is starting to ask questions. It's like back in the days when we were students. We were never asked a direct question for higher grade maths for a quadratic equation. It had to be indirect, you know? Yeah, it has to be. Sometimes you can even be given word problems, you know, to be able to solve these things nicely. So there's a lot of things to know, guys. And you just have to know, okay? You just have to know. What can I say? What can I say? Actually, I was thinking of something. You know, in the NBT, guys, these kinds of techniques will save you. Because you will have these, and then the nice thing is that there are solutions. So whatever you do, you'll be able to see the solution. But remember, some of the solutions are the solutions that come from the common mistakes students go through. So don't see something that you did and you see it there and you jump for it. Be very careful. Make sure you've done it well. Otherwise, you'll be running a risk of failing the NBT dismally. Because remember, if you are to sync students, you're not going to write the correct answer only and everything else is wrong and it's impossible. You write everything that is possible as part of the options and one correct answer on top of it all. Now, that means if you're drowning in your common mistakes, you're going to pick the wrong answer and then go, these guys are unfair. I knew the answer. I worked it out. But you performed a common error. So don't say anything. Don't say nothing. Just leave us alone, please. Anyway, students, I don't know. Tell me what you think of this course. I hope it helps somebody, especially teachers, because I'm directing this mainly on you guys who are teaching, not because I think I know better than you. No, I don't. Most of you, in fact, all of you know better than me because you've been through varsity as teachers, you know. So I'm just a fanatic. I only passed metric, guys. That's all. I only passed metric for mathematics. Of course, the one that I had to do in varsity, I didn't do proper mathematics, as in I didn't do any math major course. I did a physics type of a thing, you know. Yeah, I did physical science, Bafetsu. But now the nice thing is that the physics we did was hectic. And, you know, we had to apply concepts of differential equations and proving things. And you name all of these techniques, calculus. So, guys, at the end of the day, even if you try to run away from these things, they will find you somehow. Unless you're one of those students who just want to pass and go. I was not that type. I always wanted to understand what I'm doing, even if it meant I'm killing myself with work. I knew that when I get to work, I'm going to solve problems that many will not be able to solve. Even though we received the same training, we spent the same time at varsity, if not more, for others. But I knew that I'm here to be a problem solver, not just an addition to the numbers of people who are called a certain category. I don't believe in that, guys. I believe in that I have to make a difference. If I can't make it to myself, I have to make it around myself. If I cannot make it around myself, then I must make it as... Oh, I don't know what I was trying to say, but I got lost. Now I'm confused anyway. I feel confused. I don't even know if I said all the right things that I wanted to say. So you'll be the judge. You will tell me. Otherwise, folks, criticize this video if you want to. Correct me where you see me wrong or correct what I've said. But let me warn you though. Let me warn you. Certain things sound wrong when they're actually correct, and certain things sound right when they're actually wrong. So in maths, guys, you stay humble. You can never claim you know it all, and in fact, you can never claim that you understand it all. You just have to understand the most of it. You need to be able to handle the most of it, and that's good enough, okay? But stay humble. This subject will show you off if you're not careful, okay? So you can see that as much as I talk nonsense, sometimes boldly so, I know deep down I might just sink myself with just what I said. So don't take it to heart too much if it is harsh that is coming out of me, but don't take it too nicely, that which is perhaps motivating and good, sounds nice. It may be poison. So hey guys, stay alert. I'm nothing but a person who just keeps on trying to do the best that I can to serve you however you wish to be served. You will decide if you're going to take from my tray or you're not. It's up to you. And good luck, of course, with your next exam, and good luck with learning mathematics. At university, these techniques are going to save you a whole lot. But if you don't already have them, then you're going to struggle big time. Otherwise, folks, let me see you in the next video. Goodbye for now.